There are also some other types of generating function which we will discuss in our current lecture. So let's start our current lecture. So other forms of generating function. Now, other forms of generating functions. If a generating function f1 is given, then by applying Legendre's transformation to f1, we can obtain the other generating function. So generating function f1 we have already discussed in our last lecture, and the link of that lecture is given in description box. So if we have generating function f1, then by applying Legendre transformation to this generating function, we can obtain the other generating functions. It means we can obtain the generating functions which depends on the other variables by using generating function f1. The other generating functions are f2. And what is f2? f2 is a function of old coordinate, new momenta and time. f3. f3 is a function of new coordinate, old momenta and time. And the generating function f4, which is the function of old momentum, new momentum and time. So these three generating functions we will discuss in our current lecture. Now, f1 is a generating function which is the function of qi, capital Qi and t. It means it is the function of old coordinate, new coordinate and time. Now f2. f2 is the function of old coordinate, new momenta and time. So we will determine now here the generating function f2. For finding f2 from function f1, we use Legendre transformation. In Legendre transformation, if a is a function of u1, u2, un, then it can be transformed to other function b, which is the function of v1, v2, vn. And vi is equal to del a upon del ui. So b equal to ui vi minus a, and vi is obtained by this relation from a. Conversely, ui is equal to del b upon del vi. So a is equal to ui vi minus b. So b can be obtained by using a from this relation, and a can be obtained by using this relation. Here ui is given and vi is obtained by this relation, and here vi is given and ui can be obtained by this relation. If f2 is a function of old coordinate, new momenta and time, then old momenta pi equal to del f1 upon del qi, and new momenta capital Pi equals to minus del f1 upon del capital Qi. Now Hamiltonian or transformed Hamiltonian, k is equal to h plus df1 upon dt, and k is a function of new coordinate, new momentum and time, whereas old Hamiltonian, that is actual Hamiltonian, is a function of old coordinate, old momenta and time. Now we have to find the value of f2 by using f1. It means this is the transformation from f1 to f2, and f1 is a function of old coordinate, new coordinate and time, whereas f2 is a function of old coordinate, new momenta and time. The condition required for Legendre's transformation is f2 equal to f1 plus capital Pi Qi, and Pi Qi dot minus h equals to capital Pi Qi dot minus k plus df1 upon dt, because from here h equals to k minus df1 upon dt. So we substitute here the value of h, and a small pi is replaced with capital Pi, a small qi dot is replaced with capital Qi dot. So this is our another condition. And from here, F1 equal to F2 minus Pi Qi. So the differential of F1, that is dF1 upon dt, is equal to d by dt of F2 minus capital Pi Qi. So Pi Qi dot minus h equals to capital Pi Qi dot minus k plus d by dt of F2 minus Pi Qi. Now this is our Pi Qi dot minus h. Now we differentiate it with respect to time, and F2 is a function of Qi, capital Pi and t. It means dF2 by dt will be del F2 by del Qi into Qi dot plus del F2 by del capital Pi into capital Pi dot plus del F2 by del t. And if we differentiate capital Pi Qi with respect to time by using u into v method, then this will be Pi constant and Qi dot plus Pi dot and Qi constant. And here we have negative sign, so minus Pi Qi dot minus Pi dot Qi. So Pi Qi dot minus h is equal to this one. Now here Pi Qi dot and Pi Qi dot is cancelled out, so the remaining term is Pi Qi dot minus h equals to minus k plus del F2 by del Qi into Qi dot plus del F2 by del capital Pi into capital Pi dot plus del F2 by del t minus capital Pi dot into Qi. Now on comparing the coefficients of above equation, so if we compare the coefficient of this equation, so first of all we compare the coefficient of Qi dot. So here the coefficient of Qi dot is del F2 by del Qi, and here Pi. So Pi equals to del F2 by del Qi. So Pi equal to del F2 by del Qi. Now on comparing the coefficient of capital Pi dot, so there is no coefficient of Pi dot here, and in right hand side the coefficient of Pi dot is del F2 by del Pi and also minus Qi. So minus Qi plus del F2 by del Pi equals to 0, or capital Qi equals to del F2 by del Pi. Now we take the remaining term, so here minus h, and in right hand side minus k2 plus del F2 by del t. So minus h equals to minus k plus del F2 by del t, and from here k equals to h plus del F2 by del t. So in this way we can find the value of k by using generating function F2 and also a small pi and capital Qi. Now generating function F3, and F3 is a function of new coordinate, old momentum and time. So here we want to get the value of F3 by using F1. So the transformation from F1 to F3, and F1 is the function of old coordinate, new coordinate and time, whereas F3 is a function of new coordinate, old momentum and time. For finding F3 from F1, we use the following Legendre dual transformation. F3 equal to F1 minus a small pi Qi. A small pi equals to del F1 upon del Qi. Also Pi Qi dot minus h equals to capital Pi Qi dot minus k plus dF1 upon dt. Now from this relation F1 equals to F3 plus Pi Qi. So we differentiate F1 with respect to time. So Pi Qi dot minus h equals to capital Pi Qi dot minus k plus d by dt of F3 plus Pi Qi, and F3 is a function of capital Qi, a small pi and t. So if we differentiate F3 with respect to time, then we get del F3 by del capital Qi into Qi dot plus del F3 by del small pi into small pi dot plus del F3 by del T. So Pi Qi dot minus H equal to capital Pi Qi dot minus K as it is, and the differential of F3 with respect to time is del F3 by del capital Qi into capital Qi dot plus del F3 by del Pi into Pi dot plus del F3 by del T, and also we differentiate Pi Qi with respect to time, so Pi constant and differential of Qi is Qi dot, and second time Qi is constant and differential of Pi is Pi dot. Now this Pi Qi dot and this Pi Qi dot cancel out, so minus H equals to capital Pi Qi dot minus K plus del F3 by del Qi into Qi dot plus del F3 by del Pi into Pi dot plus del F3 by del T plus Pi dot Qi dot. On comparing the coefficients of above equation, so first of all we compare the coefficient of capital Qi dot. So here we have no coefficient of capital Qi dot, and in right hand side the coefficient of Qi dot is capital Pi and del F3 by del Qi. So Pi plus del F3 by del capital Qi equals to 0, or capital Pi equals to minus del F3 by del Qi. Also we compare the coefficient of small pi dot. So there is no coefficient of small pi dot in left hand side, and in right hand side this is the coefficient of small pi dot and also Qi. So Qi plus del F3 by del Pi equals to 0, or Qi equals to minus del F3 by del Pi. Now we take the remaining term, and remaining term here minus H, and in right hand side minus K plus del F3 by del T. So minus H equals to minus K plus del F3 by del T, or K equals to H plus del F3 by del T. Next generating function is F4, and F4 is a function of old momenta, new momenta and time. This function can be obtained either from F1 or F2 or F3. So we can obtain the value of F4 from any of the generating function F1, F2 or F3. For finding F4 from F1, the Legendre dual transformation for it, F4 equals to F3 plus Pi Qi, capital Pi equals to minus del F3 upon del Qi, and F3 equal to F1 minus Pi Qi. So this F3 is replaced with F1 minus Pi Qi. So F4 equals to F1 minus Pi Qi plus capital Pi Qi, and F2 equals to F1 plus capital Pi Qi. Also F4 equal to F2 minus small pi Qi. Now we want to find the generating function F4 from F1, and F1 is a function of small q, capital Q and T, whereas generating function F4 is the function of small p, capital P and T. So F4 equal to F1 minus small pi Qi plus capital Pi Qi. Also Pi Qi dot minus H equals to capital Pi Qi dot minus K plus dF1 upon dt. And from here F1 equals to F4 plus small pi Qi minus capital Pi Qi. Now we differentiate F1 with respect to time. So Pi Qi dot minus H equals to capital Pi Qi dot minus K plus d by dt of F4 plus Pi Qi minus capital Pi Qi, and F4 is a function of small pi, capital Pi and T. So if we differentiate it with respect to time, then this will be del F4 upon del small pi into small pi dot plus del F4 upon del capital Pi into capital Pi dot plus del F4 upon del T. So Pi Qi dot minus H equals to capital Pi Qi dot minus K plus del F4 upon del Pi into Pi dot plus del F4 upon del capital Pi into capital Pi dot plus del F4 upon del T. Now, we differentiate this term, so Pi Qi dot plus Pi dot Qi, and also if we differentiate this with respect to time, and here we have negative sign, so minus capital Pi capital Qi dot minus capital Pi dot Qi. Now, this Pi Qi dot and this Pi Qi dot cancel out. Also, capital Pi Qi dot and capital Pi Qi dot cancel out. So, remaining term are minus h equals to minus k plus del F4 by del Pi into Pi dot plus del F4 upon del capital Pi into capital Pi dot plus del F4 by del T plus small Pi dot Qi minus capital Pi dot capital Qi. On comparing the coefficients of above equation. So first of all, coefficient of small Pi dot. So here the coefficient of small Pi dot is del F4 upon del Pi, and also here Qi. So Qi plus del F4 by del Pi equals to 0, or Qi equals to minus del F4 upon del Pi. Also the coefficient of capital Pi dot. So here the coefficient of capital Pi dot is del F4 upon del Pi, and here minus Qi. So minus Qi plus del F4 by del Pi equals to 0, or capital Qi equals to del F4 upon del Pi. Now the remaining terms are minus h equals to minus k plus del F4 by del T. So minus h equals to minus k plus del F4 by del T, or k equals to h plus del F4 by del T. In this way, we can find the other generating function by using generating function F1. Here we end our session. Goodbye.